So let's talk about weather, and the next thing, the next variable, the next piece of the weather that we need to discuss. We've covered temperatures, and that's the first biggest part. Speaking of temperatures, let's examine the situation here. On January 22nd, 1943, the temperature here in Spearfish, South Dakota went from -4 to 45 degrees in just 2 minutes. Well, the question becomes, why? How could that happen? And if we think about the variables that affect temperature, elevation, well, that didn't change in 2 minutes. Latitude, how close they are to the equator, that didn't change in 2 minutes either. Well, spearfish didn't get up and move closer to or further from the water. And it certainly wasn't a change of season due to the tilt of the Earth, because the Earth doesn't change its tilt or its orientation to the sun that quickly. So the question becomes, how could we explain such an extreme change in temperature in just 2 minutes? Well, that's where this next part of the presentation comes in, and that's what this is all going to be about. This is about wind and air pressure. First of all, air pressure. You know that air is out there floating around. We talked about this with temperatures. You also understand that gravity pulls things down, including air. And that's why there's more air at lower elevations than there is at higher elevations. So you're standing here, gravity is pulling air down on top of you. And you feel it. You feel the weight of the air that gravity is pulling on top of you. Think about if this were water. You would certainly feel the weight of water on top of you if you were standing at the bottom of a swimming pool. But air, because it is so much lighter, we don't notice the pushing from the air so much. And air pushes at you from all sides because it's constantly moving around, has the energy, and it's floating around, bouncing around, hitting each other and hitting you. So air hits you not only from above, but it also hits you from the sides. So in its simplest definition, air pressure is simply the push that you feel from air particles.
So here I am on the slope of the Mauna Kea volcano in Hawaii. I'm at an elevation of about 9,000 feet above sea level, so I'm pretty high up. And that means there's not as much air up here as I'm used to down near sea level. What I have here in front of me is just an empty soda bottle. And I'm going to put the cap on it, and I'm going to collect some of the air here at 9,000 feet. And then I'm going to take it to sea level, and I'm going to be able to show you what the difference is in the amount of air and air pressure between up here up high and down low. So as you can see, I am no longer at 9,000 feet up on the side of the volcano. I have driven immediately down to sea level. That's the ocean back there behind me. And I've got that same water bottle, but the water bottle has inside of it air from 9,000 feet up. And remember, there isn't as much air at 9,000 feet as there is here at sea level. There's a lot more air here because gravity works and gravity pulls more air down low. So let's take a look at the water bottle. This is what it looks like now, because on the outside there's a lot more air than there is on the inside. Well, a lot more air means a lot more pushing, a lot more pressure. And you can see how the air has pushed the lower pressure air from 9,000 feet and kind of has crushed the water bottle. Now, if I take the top off the water bottle, what's going to happen is this outside air is going to rush into the water bottle because air always moves from high pressure to low pressure.
So a big idea to keep in mind is, remember that there is more air at lower elevations than there is at higher elevations. And we already knew that from our discussion of temperatures. Well, that means there's going to be a lot more pushing of air down here. There's a lot more air pushing on you than there is up here. So just like with temperatures, there is going to be less air pressure at higher elevations and more air pressure at lower elevations. Now here's an example of my watch which shows the altimeter, or the elevation, or the height above sea level. It's about 1,373 feet on a drive this summer, and the air pressure was 28.59 inches of mercury. That's a fancy unit. Don't get caught up in that. Let's look at that number right there. It's 28.59 when the elevation was 1373. Well, then I drove downhill a little bit. I only went down about 500 feet, and look what happened to the barometer. The barometer went up. That means there was more pressure because I went to a lower elevation where there was more air to push on me. You can see a change in pressure across elevations sometimes with food products. Now, you know, potato chip bags are always packaged with a lot of extra room in there. And if you take a potato chip bag that was packaged at sea level where there's a lot of pushing from the air, high pressure, and you take it to the top of the mountain, well, the pressure inside the bag is greater than the pressure outside the bag because there's less air outside the bag. So the bag will look like it pushes itself out because the air inside is from sea level, which has a higher pressure. So if you ever go into a grocery store up in the mountains, you might find your potato chips look blown up, or your package of eggs. Anything that has air inside of it will tend to inflate a little bit because there's higher pressure air there because it was packaged at a lower elevation where there was more air. So air pressure, the first big idea is that more air means more pushing, which means more pressure. So real quick here, check for understanding. I'm going to do this throughout the presentation. At this point in the video, in your notes, you should have a definition for what is air pressure. And you should also understand where there is more or less air pressure and be able to explain why. If you haven't picked up on that, rewind the video and make sure you have this in your notes. So moving along, temperatures have something to do with pressures as well. This is why we did temperatures first. Think about a nice, hot, sunny summer day, and the sunlight beats down on the ground, and it makes the ground hot. It makes the air on the ground hot. So this air is hot. And just like when we talk about the ocean currents, you know that hot things want to expand. They want to get bigger. And in the case of air, expanding means going up. And you already knew this. You knew that hot air rises. So you're standing right here, your air is actually going away from you, which means there is now less air hitting you, which means you would have a lower pressure because now there's less air because your air went up, it went away from you. So when you have a nice, warm, rising air, you have decreasing pressure. Your pressure is going down because your air is going away from you. Now, on the other hand, think about a nice cold winter day. Cold things want to shrink, or they want to not expand. They want to compact themselves. Well, when they get compacted, and like in the case of air, it's going to get heavier. You know, hot air is light and it rises. Cold air starts to get more dense and it starts to sink. So when you have cold air down here, now you have more air hitting you because the air is sinking on top of your head more, and that will create a higher pressure than there was before. So colder air sinks, hits you more, and will give you an increase in your pressure. These are these H's and L's that we see on weather maps. They stand for high and low pressure, and they are directly the result of, hey, is it hot and the air is rising, going away from me, making a low pressure? Or has it gotten cold and the air is squeezing together and now coming down on top of my head more? So you see these on weather maps. High pressures tend to form from places where it's a little bit cooler, especially cooler than it was before. It doesn't have to be a cold location, it just has to be colder than it was. Lower pressure is a place where the air is getting warmer and rising away from you. So another check for understanding. You should now understand, how does temperature affect or determine air pressure? What's the relationship? What does the H and the L on a weather map represent? And what temperatures go with the high pressure? What kind of temperatures causes a higher pressure, and what kind of temperatures would give you a lower or decreasing pressure? So what does this whole air pressure thing have to do with wind? Okay, first of all, we need a working definition of wind, and you know it's got to have something to do with pressure, or else I wouldn't have just spent the last 9 minutes talking about what pressure is. All right, so we have high and we have low pressure air. Remember, pressure is pushing. So I've got this lower pressure air over here because there's not as much air as there is here. And these two chunks of air come in contact with one another, and they start hitting each other, and they start pushing on each other. Well, which one can push more? Obviously, the one with more air has a higher pressure, a higher pushing, and it can push on the low pressure air. So we start playing tug of war here. We start pushing on each other. The high pressure air is going to push into the low pressure air. So the net result is I'm going to have air that is moving this way. Well, that's what wind is that movement of air. You're standing outside and you feel the air coming towards you and then it goes by you. This is what wind is. Now, what if I have two high pressures that start bumping one another? Well, one can't move the other because they have the same amount of pushing. So the air doesn't move one way or the other. I basically have no wind. You have to have one chunk of air that can push the other. One pressure has to be higher than another in order to get some movement and cause wind. Now, the fancy term for what I just described is what's called the pressure gradient. The pressure gradient is just the difference in pressure between two samples of air. Now, if you have a big difference in pressure, you have what's called a large pressure gradient. And well, we still got a difference here, but it's not as big. So we say the gradient is not as large. If they're the same exact pressure, or practically the same exact pressure, we say there is no pressure gradient because they have the same amount of pressures. There's no change from one sample to the other. Now that pressure gradient determines how strong the wind is going to blow. If you have a big difference between the pressure here and the pressure here, it's going to move very quickly and very easily, and you're going to get a nice strong wind. A large pressure gradient is going to give you a stronger wind because it's going to have an easier time pushing or moving to the other air sample. Now in this case, we don't have quite as big a difference. So this high pressure is still going to push into the low pressure, but it can't push as quickly because the low pressure one isn't as low. It pushes back a little bit more. So not as big a difference in pressure means you're not going to have quite as much wind. You still have a little wind, it's just not as strong. This case here, when you have no difference in pressure, nobody moves. You have no movement of air because they have the same pressure. When you have no movement of air, you have no wind. So you have to have a difference in pressure, or you have to have a pressure gradient in order to get air moving and hence have wind. So what direction will the wind always blow? Air will always move from high to low pressure. The lower one never pushes on the high one. So if you can find this H on the weather map, you know it is going to move towards or push towards the L. So another check for understanding here. You need a good working definition for what wind is. Well, and if we want to know what wind is, we want to know which way it's going. And there's one factor that always determines which direction air will move. How will it always blow? Which direction will wind always move? This whole idea of pressure gradient that I just discussed. Let's define that and be able to say what is meant by when I talk about the pressure gradient. And we're going to use that to predict, well, what's the difference between a strong wind or little or no wind? What's the pressure have to do with making a strong wind or a little or no wind situation? All right, so going back to temperatures and pressure, we get the hot air rises, so the air goes up, and now there's less air, which makes a lower pressure. And cold air is going to sink, so there would be more air on top of you, which make for higher pressure. So think about the Earth, and sunlight comes from the Earth, and it hits this part of the world very directly all the time. That means the air at the equator is always hot, and we knew that. But what does hot air do? Hot air tries to rise. and that's what the air at the equator does. But it can't rise indefinitely. Gravity still works, and gravity is going to keep the air close to the Earth. So eventually it's going to go up pretty high where it's going to start to get kind of cold and it wants to sink. But it can't sink at the equator because it's always getting sunlight and more air is rising behind it. So what happens with the air? It expands the only way it can. It goes that way. Because then remember, there's more air coming up behind it, which keeps pushing the air this direction. Well, what do you know about this area up here and this area up here? Well, that's where it's cold. And what does cold air do? Cold air sinks. So air at the equator tends to rise, and then it expands, and then it gets to this part of the Earth where it's not as warm, and so it sinks. Well, this process constantly happens. So what you end up having towards the equator is you have a lower pressure area, and near the poles you have a higher pressure area. And remember that air always moves from high pressure to low pressure. So now I've got high pressure here, and along the surface of the Earth, air is going to move this way. Well, when that air gets back to the equator, it's going to get hot again, it's going to rise. So we basically have this pattern where air moves like this. Goes to the equator, gets hot and rises, expands away from the equator, gets cold, sinks, makes high pressure that pushes itself back to the equator again. There is a name for this type of movement of air in the atmosphere. It's called a Hadley cell. A Hadley cell is just this pattern of circulation. A Hadley cell is hot air rising at the equator, moving to the poles, and then sinking. It's also low pressure air at the equator and high pressure air at the poles. So what difference does that make to your weather? What does high pressure air and low pressure air mean for you on a daily basis? Well, here's what high pressure air looks like. You get a lot of air near the ground, a lot of pushing, and our water, especially in the oceans, gets trapped in the oceans. We know that water loves to evaporate and go up into the air, make clouds, and then make rain. The problem is when there's so much pushing down from air, water has a really hard time evaporating. So when you have high pressure air, most water is kept down or pushed down onto the ground. Without water in the sky, you can't get clouds. So low pressure air. Well, if you relieve some of the pushing down on the water, this water can evaporate much easier because there's not as much stuff pushing down on it. Well, that means low pressure water can get up here, and when you get enough water up here, you'll get a cloud, and then if you get a big enough cloud, you'll get rain. So here's an example of what high pressure air looks like. Notice what's missing in the sky. There are no clouds because clouds are water. So what we have happen here, we have high pressure, which is pushing down, and it is keeping all of the water down here. So we don't get any clouds. If I see a high pressure day, I know it's not going to rain. It's a good day to go outside. It's going to be sunny. Go play golf that day. On the other hand, here's low pressure. So without much to push the water down, the water all went up into the sky. And in this case, it went up in the sky very easily and very rapidly, and it was able to form these nice, big, nasty, stormy rain clouds. And this cloud is getting ready to blow up in a really nasty thunderstorm. Well, that's very common of low pressure. So if you see that the pressure is going way down, or you have a very low pressure day, don't make plans to play golf, because odds are you're going to have clouds forming and then probably rain. So another check for understanding here. Be able to describe what this Hadley cell thing is, and what the pattern is of the movement in a Hadley cell, especially as it relates to the equator and the poles. Then Well, describe what's it like if you have a low pressure day or you have a high pressure day. What would you see outside in terms of the weather? So how do we know where all these high and low pressures are? Well, we need some devices that we got to use to measure what the pressures are. If we want to be able to say, hey, it's going to be a high pressure day or it's going to be a low pressure day, we got to measure the pressure. We also need to measure the wind speed.
So what we have here is a barometer, which is the measuring device that is used to measure air pressure. Now this barometer has a couple of different scales. It's got this one on the outside, which is inches of mercury. It's got centimeters of mercury in there, and it's got millibars. Well, you can see the pressure today is just over 29. And notice it has an arrow on there for falling and for rising, because what the barometer is doing is going to tell us a lot about what the weather is going to be like. How is it going to change? How you use this? People would take this gold bar here, this handle, and they would put it right there in the morning, and they would see what the pressure was. And then they would come back later in the day, and it would allow them to see if this handle was rising or if this measurement of pressure was falling. If I came back later in the day and the handle is up here, I know the pressure has gone up. Well, a rising pressure means nicer skies, clear skies, so I'm probably confident it's not going to rain. If I came back later in the day and my arrow was now less than where it was this morning, the barometer is falling, which makes me think that more water is going to evaporate into the sky. It's going to be cloudier with a greater chance of rain. Well, today, this number's on the low side. This is a pretty low pressure day for us. So let's take a look at the skies. And you'll notice the sky here has a lot of clouds in it, meaning there wasn't a lot of pressure keeping the water down on the ground. So water was allowed to rise in the sky and form these clouds, which this kind of sky is very much associated with low pressure conditions. And we can see that from our barometer reading. Once again, a barometer is the device that is used to measure air pressure. So this here is an anemometer. A-N-E-M-O-M-O-T-O-R, anemometer. And this is a device used to measure wind speed. And you can see how it works. As the wind catches those cups, it makes the cups spin. The faster the cups spin, the more this orange part on the bottom is going to rise up the post. And you can see the numbers on the post gives you an idea of what the wind speed is based on how fast these cups are moving. You can see today, the flag back there in the background, it's not very windy, so it's a pretty calm day. Not much wind to measure, but you can see there is some air moving. Now this here is a little bit more modern, a little bit more accurate anemometer. You can see the little device that's got a blade in there, kind of like a fan, and when the wind hits it, it causes it to spin and rotate. I'll turn it on. The faster it blows, the higher the wind speed. And you can see the wind speed today is 0.9 or 1 mile an hour. It's not a very windy day. But once again, an anemometer is a device that is used to measure wind speed.
So we get all this data, we figure out, which direction the wind is blowing and what the pressures are, and how do we organize this so that we can see it. You'll take a map like this, and those numbers on the map represent an air pressure reading. And you'll notice over here we've got an H because it's at the biggest number of 1028. The 1008 is the lower number, so it's near the low pressure. Now, these lines can tell us when we have windy or not windy conditions. Remember, if the pressure is changing, if there's a big gradient, you're going to have a lot of wind. Well, if you look right here, there's a lot of lines there. Think about each line as being like a step, or one more higher measurement or one more lower measurement. Well, we got a lot of measurement change over here. We got a big difference between pressures, which means we're going to have a lot of wind. Same over here. We're going to have a lot of wind because they have a big difference between pressures. Now, in these areas in here, notice there aren't any lines. There aren't any differences in pressure, which means all the air is the same, so the air is just sitting there. There's no wind. Same concept here. Notice those lines are close together, so you're having a big change in pressure. Each line represents a change in pressure. So where there are a lot of lines, you're going to have a lot of change in pressure, which means a lot of wind. Down here, that whole area has no change in pressure, so there's going to be no wind. Now, the H's and the L's, they go according to what these numbers are. That's a 1024. See, 1016, 1020, 1024. That's my center of high pressure. Here's my lowest number of 1004. So that's my center of low pressure. These lines on these types of maps are called isobars. An isobar is a line that is drawn on the map that shows you what the pressure is. And we use these to figure out where and how much the pressure is changing, because that will tell me if it's going to be windy or not, and what the conditions are going to be like in the future. If I know it's very windy and there's a lot of air coming towards me, that's going to tell me something about what my conditions are going to be like later on that afternoon or the next day even. So what can we tell from these types of maps? We can tell where it's windy and where it's not windy, where the high pressures are and where the low pressures are. So on this map, where is it sunny and where is it cloudy? Remember that sunny is where high pressures are. So it'd be sunny skies right there, sunny skies right here. Where is it cloudy? Well, it's going to be cloudy around the low pressure systems. Take a look at this map. A, B, and C. A is going to be a windy location because there's a lot of lines there. A lot of change in pressure, big pressure gradient, a lot of change. B is going to be sunny because it's the high pressure, and C is going to be cloudy because it is the low pressure. All right, so a final check of understanding before taking the notes quiz. You got to understand what a barometer is, what it's used to measure, what an anemometer is, those isobars, those lines in the map, and how can we tell from isobars in the map where it is windy or not windy. So once you've finished all these checks for understanding, make sure you have that information in your notes. Come see me and take the notes quiz and get a good grade.